Yeah, I just wanted to show you what the latest upgrade is that I'm using inside of here. This is the control box. Now I had that motor controller that went out on me, so I since replaced it. So the one that I had was this one, and I thought it was the chip on the top, so I bought new chips and I put them on here and it still didn't work. So then I guess, so it must be the board was bad. So I ordered another board and it didn't come in. But meantime, I ordered 3 of these. Now these are smaller motor controllers. And this one only uses 9-volt power supply. And I tried it and it didn't work. I guess it just didn't have enough power. So what I ended up going with was the green one, which is the same one here as I used for the rotation on the top. So now I have a green one, which is like this, that's going to control the 0 to 90 degree rotation. Now the thing with these are mostly for small stepper motors, like for 3D printers and what have you. And I think this one worked, but not when I had, a lot of load on it. And that might have caused the board to not work, burn up, whatever the case may be, I don't know. And like I said, I tried this one and it didn't work at all. And the thing with these boards is I had to solder the connections onto them, onto the motor and on over here. And the only ones you could screw in are the power supply, and that was 12 volts, 12 to 24 volts. And this one here was the same thing. I had to solder the wires onto there, and then I put pins in there and soldered the wires onto there, and then you have to set the potentiometer, and on both of these you had the potentiometer on top you had to set. But the thing is that, with this one I know it works because I've used it quite a few times before. And I've used it a lot and it works. And it's a lot easier to set up. You just put the wires in there and you tighten the terminals down on both sides. Then you can set the dip switches here according to the chart in the middle. You don't have to worry about setting the potentiometer, and you can set the rate at which it spins, the micro stepping and all that. And it's only, a couple bucks more than this guy, and it's like the better choice is what I'm trying to say. This is an old one that it got damaged a long time ago right here, so I just leave it laid around. But I put a new one in here, and you just saw it operate not too long ago. So I gotta basically just button this back up. I wanted to show it to you while it was in there. Now on this one, I had this cover on the bottom, went like this, so that's why you really never saw this. You may have seen this side. This is the one where I put a fiber board in here to protect the components against hitting anything. And I had this attached to it. But since this board is taller than this one that I had in there before, I couldn't fit the bottom piece on here. So I had to take this off. Little mount I made for this. This is supposed to be mounted with this to the bottom, but it never really worked out, so I just left it on there. But now I have to remove that because I need that little bit of extra room to mount that plastic piece in back in here. And this stays the same. And the wiring for this new one is this is what I ended up with. Now this is looking at it just like this with these dip switches over here. So you got the CL plus, which is the step, and the CW plus, which is the direction. Then you got the EN plus, which there's nothing connected to that. So the CLK minus, the CW minus, and the EN minus are all connected together. Then they go to ground. Now the step and direction happen to be blue wires that I have on there, and they can be switched. All it does is turn the motor in one direction or the other direction. Then of course you got your 12 volts to 24 volts input. Then you got your ground. Then you got your stepper motor leads. This is the color of my leads on my motor. That's the stepper line motors. Now I'm not sure about this board. It's motor controller board. It's the green one. Everybody knows, seen that quite a few times. I'm not sure if it's a 6050 or something like that. I just happened to write that down. And I set the potentiometer on this, and the potentiometer I'm using is this one here. That's the one that I ordered 2 of those last time. I'm using one of them, and it's working good. The one I had before, I put the 12 volts into it and only needed 5 volts, so it kind of went crazy. And as far as the potentiometer settings, which I talked about in the program, this is the original settings, the 0, 1023, 1000, 0. That's the original settings down at the bottom of the program. And I changed it to this, and it wasn't giving me the program. When you go 90 degrees, the original program isn't for 90 degrees, it's for the full rotation of the potentiometer. But I only wanted to use the 0 to 90 degrees, so I had to change it. And the number I ended up with is 1325, which goes on the third one. The first one is 0, 1023, and then I changed that to 1325. And I also changed the second one from 1023 to 500. So I got 0, 500, 1325, and then 0. And that's in the bottom of the program. I talked about that before. But that's the number I ended up with to get the 0 to 90 degree right. And what I had to do was I had to put this on the computer, and I set that like that, put the number in there, and then I rotate it 90, and if it was still off, I changed the number, and then I just kept rotating this on a 90 till I got to where it looked where it was supposed to be, and it come out pretty accurate for for this potentiometer that I'm using. Now, of course, if you use a different potentiometer, you're going to get a different reading, and you might have to get different number. And you know, if you were going to go this route, what I would have done now is that instead of going through all this that I went through, I would have had the axle of the rotating unit, and I would have fastened like an arm to it. Of course, this is exaggerated, but there'd be a series of holes in here, or even a slot, and then you have your potentiometer over here with an arm fastened to that. You'd have a link between here and here, and if you wanted your potentiometer to move more, you would raise your link, and that would give it greater stroke. Or if you wanted it less, you would bring this down, and that would give it less stroke, so give it less reading. Now, I would have done something like this to get a more accurate reading while it's on the unit, because you could just simply adjust this up and down. This is similar to what they use in the RC industry, whether it's a car or a boat or an airplane. You have the servo with a servo arm on it, and it's got different holes in the arm, so you can change the rate of the throw by moving your link either to the outside or to the inside. And that would have been pretty much the easier way to go. You could have just mounted this on the framework or wherever you want to mount it, and then this would activate, and it would give you a more accurate reading. Now, as far as the reading on the 0 to 90, it flickers a lot, and I think a lot of that has to do with it. It's a 5-volt input, and I got my 5 volts powering the screen for the indexer. I got it powering the fan. I got it powering some of these Uno pieces. And I think if I wanted to stop that flickering, I would isolate that one screen with its own power supply, so it wouldn't be, you know, catching interference from all the other attached things to it. But right now it's not that critical to where I have to put an isolated power supply on that one screen, because it's doing what it's supposed to. It's just not very clear. But later on, if I wanted to make it crystal clear, I would put a separate 5 volts into that one system and isolate it from the other systems to make it a lot clearer. Of course, I can always do that later, but right now, you know, it's prototype work, and, you know, we're just getting it, you know, going. And later on, we can always, you know, come back and fine-tune the different things, but the idea is to get it up and running and make sure it works correctly. It don't have to work perfectly the first time, but it's got to work correctly, and we still got a number of things to do, so we don't want to spend a lot of time making one thing perfect while the rest of it is basically a general type thing, and we want to get it going. And once we get it going, then we can go back and perfect the different systems as needed. But the one thing I did do is I put in a additional switch. I got 2 switches now, and one switch operates the 5 volt system, and the other switch operates the 12 volt system. The 5 volt system being the LED screens, the fan, power to different boards. I got 7 volts going in here, 5 volts. So this one does the 5 volts and the 7 volts, and this one is for the 12 volts for the motor for this one and for this one, the rotation on top and the 0 to 90. And I did that because I read somewhere that when you're working with these boards, you're supposed to put the 5 volts in first, let it stabilize, and then put the 12 volts in. Now I don't know how accurate that statement is, but it's not a big deal to add another switch and let the 5 volts go in there first and turn on all the displays and everything, and then turn the 12 volts on to actually power the motor. I mean, it's not that big a deal, and maybe the person knows what they're talking about. Maybe they don't, but hey, all I do is just wire up another switch. That way I'm safe. So I got to make a new mount for my switches. I only had a mount for one switch. I got to make another switch mount which has 2 switch holes in it, which is no big deal. But so I'm ready to button this thing back up, and now that we got that motor controller working, we can move forward on something else. So that's the update on this now. All right. Talk to you later.